Welcome to the Tech Talks Daily Podcast, where you can learn and be inspired by real-world examples of how technology is transforming businesses and reshaping industries in a language everyone can understand. Here is your host, Neil C. Hughes.
Welcome back to the Tech Talks Daily Podcast, where we cover a different topic every single day around how technology is transforming our life, work, and world. And today, Matthew Rocklin is going to join us. And Matthew is the creator of Dask, the popular native distributed computing library. And he's also the founder and CEO of Coiled, which helps teams run Dask in the cloud. Now, as the past decade has seen a huge boom in the number of open source tools built specifically for data scientists, we can't ignore the fact that most of these projects struggle to gain wider adoption. But Matthew appeared on my radar as one of the few leaders in the developers tool space who knows how to build things that data scientists love. And he believes that in order for any data science tool to be successful, it must be human-centric. And data science is a diverse field, and it should really be easy for any data scientist to pick up a tool and easily adapt it to their own unique use case. So for those reasons alone, Coiled was built on the success of Dask and is currently being used by thousands of data scientists and engineers in organisations in everything from NASA, Capital One, Anthem Health and USAF to combat climate change, perform credit risk analysis and manage supply chains. So we've got a lot to get through, that's what I'm trying to tell you. So buckle up and hold on tight as I beam your ears all the way stateside so that you can join me and Matthew in conversation now. So a massive warm welcome to the show. Can you tell the listeners a little about how you got here and ultimately share your origin story with everyone and where your passion for technology came from?
Hey, Neil, it's good to be here. So my name is Matthew Rocklin. My passion for tech, I'm not sure I have a passion for tech. Yeah. I think I have a passion for getting some things done, and tech just happens to be a nice way to achieve that passion. So tech is a how, not a why, I think. Yeah. So I think my background, so I had sort of more of a scientific background. So I studied physics and astronomy in school. And what I found is that I knew a bit of programming at the time, and that made me more effective than I would have been otherwise than my colleagues, because I could do things that they couldn't. I found that was really empowering. I really appreciated that increased agency that software development gave me. And so as I went off into a science career, I eventually switched and actually split off into doing more open source software development in the Python space. Python is a language that was really commonly used by scientists. It was actually used by scientists before it was used by data scientists. Python has a really large and rich history in that space. And what I found is that by working in companies that were doing open source Python software development, I could have an impact across lots of different domains and lots of different fields that I cared about. Human health, biology, climate change, governmental reform. All of these things were things I could touch upon in a nice diffuse way, rather than being focused on any particular one of them. So I think where a lot of the sort of Python software developers came from, we came from this sort of save the world mentality, and software ended up being a convenient path to have a large impact.
What a great story. And one of the reasons I asked that is to find out more about what put you on this path. And I love how it kind of began with astronomy and physics. And then from there, of course, you went on to become the creator of Dask, which is a popular Python native distributed computing library. And you're also founder and CEO of Coiled, which helps teams run Dask, but in the cloud. So for people that are hearing about these two companies for the first time, can I ask you set the scene and tell me more about the story behind them and also the problems ultimately that you set out to solve?
Yeah. So as I mentioned, Python was used to solve a lot of science problems. And what we found is that the business community found that Python is also great at solving lots of business problems. So if you start with maybe Excel to do data analysis, as your data gets too large or as your computations become too complex, you have to switch to some kind of programming language, right? And so it could be a really serious programming language like C, C++, Java. What we found is that these languages weren't actually that successful for sort of semi-technical people who had some technical ability, but were mostly focusing on the business. They're mostly focusing on the data. They were focused on some other thing. They weren't software engineers by profession. And Python because it was focusing on scientists and it being a good language for these sorts of folks. What we found, though, is that as data sets got even larger, people wanted to use multiple computers to solve larger problems. So, if you have a gigabyte of data for all of your customers, you might be able to do that on one machine. But if you're a larger company, if you have a terabyte or a petabyte of data to process all of your data of your customers, that becomes more complicated. And so people were shifting from really friendly, really easy to use languages like Python into a bit harder to use languages, a lot harder systems like Spark or MapReduce or Hadoop. And these systems could handle larger data sets, but weren't as easy to use. And so this split between using Python on a single machine and using a system like Spark or Hadoop on many machines caused a lot of tension in organizations. And so I was working at Anaconda at the time. Anaconda was the for-profit company in Python open source. And we wanted to solve this. We wanted to have a Python native way to scale out and let non-technical people operate on very large data sets, provide business value to their companies. And so we made Dask. So Dask was an effort to do just that. So Dask makes it easy to scale out Python onto many machines in a variety of different ways. And so it's really all about connecting humans to large computational resources. I think if you've got a person trying to solve a business problem, if you have 1,000 computers that you need to solve that business problem, how do you connect that person to all those machines? So there's lots of technologies in the way, and Dask is one layer in that stack. Over time, Dask became very popular in a grassroots way. Many individuals and companies use Dask. What we found, though, is that very few companies use Dask. We had succeeded in getting the bottoms-up adoption of a technology, but there wasn't much for that bottoms-up growth to go. It was actually challenging to solve some of the more organizational challenges. And so we made a company behind Dask, Coiled. This is quite common today to see a for-profit company married to an open source package. Where Dask is a bit different and where Coiled is a bit different is that the software package is quite a bit older than the company. And so we're much more mature as a software community than we are as a company. So that's been an interesting effort trying to come up to speed and get to the same level of adoption as the software packages.
And you mentioned Anaconda a few moments ago. We did have Peter Wang on here a couple of weeks ago. Mm-hmm. And tech is a small world. Presumably you've met in a previous life too?
Oh, yeah. No, I used to work for Peter. Peter's great. And also all of the open source world is pretty well connected. Right. We all used to do this in our homes, in our garages, in our spare time. And now we're all running companies. It's a very interesting progression from this community effort, this volunteer effort, into VC-backed, funded, negotiating with Fortune 500 companies approach that we have today.
And if we look back over the past decade alone, I think we've seen a huge boom in the number of open source tools built specifically for data scientists. However, most of these projects often struggle to gain widespread adoption. But you are one of the few leaders in the developers tool space who knows how to build things that actual data scientists truly love. So, which is no small feat, let me tell you. But can you tell me more about your belief that in order for data science tool to be successful, essentially it's got to be human-centric? Because it seems so obvious, but not many do that, do they?
Yeah. So first, I would reject the idea that I know how to do this well. I think there's a lot of luck involved, and I would say if there's a trick, I would say it's probably humility. Yeah. Right. So I actually made lots of software projects where I thought this is going to be the thing that's going to solve the world. This is going to be the thing that's really going to make everyone's life a lot better. And they didn't get any use at all. That's because I was wrong about what people needed. With Dask, I took a different approach where I said, I'm not going to build a feature until I can find people who will actively use that feature as I'm building it. And that actually forced me to be very receptive to information, be very, very open, and have, again, as I said, more humility about what to build. Many software developers want to build the next great thing, but we actually don't have great empathy for the users that we're serving. And that's actually a really hard point. And so I think that so you mentioned human-centric, which is something we often talk about at Coiled and Dask. I think that we when I was first building Dask, I asked Wes McKinney, who's the creator of Pandas, a very popular library in Python space, probably one of the most popular libraries, how to build good software. And he said, find a user community who has pain and solve their pain. And really being sensitive to that pain and orienting all of your efforts around that pain is, I think, what causes great software. And it's not being brilliant. It's not being creative. It's just about being sensitive to and fixing pain quickly and about failing quickly. And you can see that in Dask today, right? You see that in Python today, right? So Python is not the best language. Python is actually a pretty terrible language from a computer science perspective. But it is really easy to use, and it's really common in education, right? And it's really well supported by developer tools. And so actually the things that make a language great or make an ecosystem great aren't the technical aspects. There are the aspects that are about user experience. So if you take this onto Dask, Dask is really easy to install. It's really easy to configure. These are things that we heard time and time again from users of other tools like Spark. They were quite challenging. Dask fails really gracefully. It's really frustrating when your cluster of 1,000 computers breaks down, because it's really hard to debug. You got to go into some other computer, figure out what's wrong, and fix that. And so Dask fixes issues like those. Dask has a really lovely interactive dashboard that tells you what's going on. It's actually not a performance tool, but it doesn't help you scale, doesn't help you achieve great things, but it lets you know what's happening. And if you ask our users, about half of them, more than half, you can ask them what their favorite feature is. Like, oh, it's the dashboard. Something that lets me know what's going on, that visibility. What a lot of technologists get it wrong is that they focus on the technology. They focus on the capabilities of the technology, rather than focusing on the people that are using the technology and what their experience is like. And that's where I think if you look at, a Tesla or some other excellent product out there that's in the consumer space, it's not so much that it's an electric vehicle, it's that it's a very smooth drive, right? It's a very sleek looking car. There's different aspects for why people use technologies other than their primary feature. And that's something I think you learn a lot as you talk to lots of users. What they want, what they need is quite different from what you think they need. And it's that humility to listen to them rather than yourself that I think creates great technologies.
I completely agree with you. And your humility really shines through today. So this next question is probably going to be a little bit difficult for you. But one of the questions I wanted to ask you on behalf of any founders or any builders of tools out there is, what do you think the secret to building a human-centric developer tool that thousands of developers love? What's the secret to doing something like that? I know, obviously, you're far too humble to say, well, I'm not the guy that does it. It's a whole team of people. But ultimately, if you zoom out, what is it that is that missing piece that so many forget?
Yeah. So I think, as I was saying before, I think empathy is a big issue, and humility, right? So, and maybe failing fast. I think many people who are in this sort of open source journey trying to achieve, some great technology, you get into this state where you think, if I just build these 5 new features, then people will use it. And it's always a month or 2 months away in order to get enough features that people will start using your technology. And when you're in that state, it's usually a bad sign. You should experiment with something for a week and see if you can get a user. And if you can't do that, then you should stop and you should try something else. I think there's a lot of failing fast, and there's a lot of being sensitive to users. And that's what I think we've done well. The original Dask design was very different, and the scope was very different from what we achieve today. If you had asked me to make a company, 5-7 years ago, we started the project, the marketing materials we would have had for that company would be very different from what we have today. The scope is very different. The whole thing changed. We had to pivot 5-6 times before we found the right mix. And so pivoting quickly, failing fast is, I think, critical for success, at least in our situation.
And when I was doing a bit of research on you guys, I quickly learned a few breathtaking stats. And that is around that Coiled helps run large-scale data analysis in the fastest and most reliable way. And to bring that to life, it currently manages over 2.7 billion tasks for more than 2,600 data engineers and data scientists, which is just mind-blowing. But can you offer any additional use cases or client stories just to kind of bring all that to life that we're talking about today and help people understand how all this could benefit their people in their world and their business?
Yeah, sure. Let me actually first just give a clarification on those numbers.
Yeah.
2.7 billion tasks. I think we put that marketing material out in our first few months. It's probably trillions at this point. I mean, a task is just running some Python function on some machine. And I've generated 2 billion tasks historically, so it's not a big number. But yeah, let's get some use cases. So let's talk about. I'll give you a couple. In maybe in science and in an industry. We'll start with industry. If you look at a big bank, so lots of banks use Dask, and they do things like credit risk analysis. So maybe you're a credit card company and you want to assign a value to a customer. And you've got 100 million customers. Every customer has got an age and an ethnicity and a postal code or a state or a region that they live in. And you might train a machine learning model on all that data and find that people who are bankers living in Manhattan tend to be worth a lot of money, and people who are, students in Chicago tend to be worth less money. And so you make a machine learning model, and you'll use that model to assign value to new customers. And, 100 million rows in your data set for roughly 100 million customers. You can fit that and train that on one machine. But now let's say you want to look at a richer data set. There isn't just one line per customer, but maybe one line for every transaction a customer has done. So look at think about your credit card bill. Think of every little line in there. Now they're going to train on all of that data. And when you do that, you might find that the banker in New York City actually has been drinking a lot of vodka. They've been going to the betting, the horse track. They're actually exhibiting a lot of risky behavior. You might downgrade them a little bit. Certainly, the student in Chicago might be going to the University of Chicago, an excellent school, and they're actually they're buying groceries and they're paying off everything in time. And so that might give you actually a richer ability to evaluate your customers and build a more effective training model. And for a customer like, let's say, Capital One, this can be 1%, 2% improvements in that machine learning model can result in billions of dollars of increased revenue. But that data set is 1,000 times larger than the data set where you have one line per customer. And so you actually need hundreds of machines to train that data set, train that model for that data set. So that's the case for something like Dask could be useful. So that's one example. Another example, you said you're in the UK. So there's the UK Biobank and the US Veterans Affairs, the USVA, are trying to look at the genomes for 1 million people. It's called the Million Man Genome Project. And they're looking at a lot of, so in about 2000, we sequenced the human genome. Mm-hmm. So the human genome has about 2 billion base pairs. You've probably heard at one point. So that's about 2 gigabytes in your computer. So you can actually load one genome in your computer and look at it. It's a neat thing to look at. You can try to see, here's the gene for hair color. Here's the gene for, eye color. But when we try to pair that with not one genome, but a million genomes, and also with medical records for all of those individuals, we can try to pick out, here's a sequence of genes that might cause Alzheimer's. Here's a sequence of genes that might cause susceptibility to certain kind of cancer. And so that kind of more statistical population genomics has, possibly incredible benefits to human health, and is also, a great financial opportunity for whoever cracks this. What it requires not, 2 gigabytes per person, and you've got a million people, you're now in sort of the petabyte range. That's actually quite a bit more challenging. So this is another situation where when you increase the size of the data, you get a much richer view on the world, but you now have to do a much larger computation. So this is where, again, you want to combine these sort of scientific, sort of business analyst users with massive amounts of compute hardware. So these are both two examples where I think Dask's done very well, and that are, it's fun and it's nice to see both the potential business impact and the potential humanitarian impact.
And on top of that, I was also reading that your company raised a $21 million Series A fund from Bessemer Venture Partners and other top VCs. So I'm curious, how's that funding going to help not just yourselves, but your customers as well? And what does it mean to you?
Yeah, so it was 6 months ago a great time to be raising money as a venture-backed startup company in the tech space. Yeah, so mostly what we do today. So Dask, as I said, has widespread adoption among lots of different groups, and some of the money goes to improve Dask. to connect it to different verticals, connect to different technologies that are out there, and to make it more solid and stable for all of our users. But mostly what we're working on right now are ways to make it easier to deploy Dask in cloud settings. So most of the companies today that are using large data sets to train models to achieve business value are transitioning to the cloud. And the cloud makes everything much easier to deploy, but it's still not easy. There's a wide gap between that individual data scientist and quickly renting 1,000 computers in the cloud in a safe and secure way. What we found was that lots of folks wanted to use Dask, and they were using Dask for proofs of concept, for early experiments, but that shifting this into a more production setting, shifting this into a way that the entire company could use reliably and safely in a way that IT was comfortable with, required a more sort of IT-friendly stack to build on. And so most of that money is going into building that stack. And so this makes it, a person can press a button and get a cluster that satisfies all their internal compliance reasons. So that's what we're focused on right now, as well as a standard, get the word out and sort of sales process. But it's really building that highly robust, highly mature, highly dependable cloud deployment stack on top of Dask. That's really the biggest value that we can add to the world today.
Well, I cannot thank you enough for coming on here and sharing your story and the work that you're doing. But we've now reached the part of the podcast where I always like to ask my guests to stare into their virtual crystal ball and tell me a little bit more about what they think about the future. So in your case, I'm going to ask you a pretty big question here, and that is, what do you think the future of distributed computing looks like, and how do you see that evolving based on the kind of trends that you're seeing at the moment?
Yeah. So first, let me rely back on that humility aspect, right? So I don't know the answer to these questions. No one knows the answer to these questions. Whoever is telling you the answer has listened to themselves a bit too much. But I think what I, from my perspective, and I've got a very limited view on this space, from my perspective, what we're seeing is an increase in access. So previously, distributed computing was something that you had to have a PhD in order to do effectively. And right now we're making it, we and many other companies in this space, it's a very hot space. Many companies are making it easy for lots of people to do this, right? It's still, you need to know how to program, but that's about it, right? And it's much more approachable than it used to be. And that's, I think, where we're going to see the most gains. I actually don't care that much about, faster algorithms or going to, bigger scale. Most people don't need 1 million computer cluster. They need 20 machines operating in concert. They just need it right now. They need it more easily. And they need it in a way that their organization can accept. And that's, I think, where we're going to see the biggest impact. It's not in research. It's in ease. And that's, I think, where we have a lot more impact. Not just for distributed computing, but for computing in general.
I love that. And outside of predictions, is there anything in particular that excites you about the future and where we're heading?
There's this whole trope about data is the new oil, right? Or electricity, or AI is new electricity. And all these things about how we're gonna change the world in this massive way. And we've been doing this for the last 20 years or so. Smartphones are faster, and data access is easier. Maybe we're starting to see a little bit more of that, though. I think when these changes start affecting daily life, when my parents actually just got a cell phone that was last week. They're quite on the opposite end of the technology spectrum, but as their lives start improving from improved weather access if they live in a hurricane affected region, or as their life expectancy expands. That's, I think, where we're starting to see the real benefits. So I think it takes a long time for the benefits of the last 20 years to trickle down into everyday life. And that's, I think, what excites me, is seeing that hit not tech companies, but retirees, or hit children. That's where some of this stuff gets more exciting, I think.
Yeah, completely agree with you. And we started our conversation today talking about your origin story, what put you on this path. And as we've come full circle, I want to tackle how none of us are able to achieve success without a little help along the way. So is that a particular person who you're grateful towards, or somebody that just helped you get where you are that you'd like to give a shout out to now and a thank you?
I'll maybe tweak the question a little bit. So not a particular person, but I think that the open source community was quite welcoming. There's actually this interesting. So when I first started software development, I jumped onto a GitHub repository. I started fixing some bugs, and people said, "No, you're doing it wrong." They helped me along the way. And that wasn't one person; that was hundreds of people. There was actually a very strong community that was all volunteer based at the time, and that was actually really, really welcoming. That changed my life, and I tried to do that also for some other folks. And I'm sort of happy for the impact that I had. But that community is really special. I think a lot of us, especially sort of in the open source scientific Python space, benefited a lot from that. I hope that as more money gets poured into this space, we don't lose that esprit de corps, that community aspect. If I were to call it a few individual people who helped in there, I think you mentioned you had Peter Wang on your show. Peter Wang, Travis Oliphant. There are some folks who I think really pioneered the sort of for-profit open source approach that I and many people like me are now benefiting from. And that's hard, right? They did a thing that was not typical, so that others could follow in their wake in much more smoothly. So I would think everybody in that space, but I would call out maybe Peter and Travis is especially impactful.
Wow, that's a beautiful answer. I always say somewhat cheesily at the end of every episode that technology works best when it brings people together. And you giving a shout out to the community is a great example of that. And before I let you go, though, for anyone listening just wanting to find out more information about Coiled, Dask, anything that we explored today, or even contact your team, what's the best starting point for everything?
Yeah, so again, we've got a for-profit company, and that's coiled.io. And then there's also the open source community is dask.org. Both websites will get you to where you need to go.
Awesome. Well, thank you so much for sharing your personal entrepreneurial path, how to build human-centric developer tool that thousands of developers love, and did that with humility too, and also talk about the future of distributed computing. So just a big thank you for sitting down with me and sharing your story today.
Yeah, thanks for having me today, Neil. Cheers.
So a huge thank you to Matthew for sharing his entrepreneurial path, not to mention daring to explore the future of distributed computing with me. But over to everyone listening, I know we have a lot of developers, we have a lot of business leaders listening, a lot of techies. We have such an eclectic mix of people listening from all around the world. And it's your voice, your experiences, your insights that make this show what it is. So please email me anytime, techblogwriter@outlook.com, LinkedIn, Twitter, Instagram, just @NeilC.Hughes. Let me know your thoughts on what you heard today. If you'd like just to send me a quick message that you'd like me to read out on the podcast, if you leave a rating and review, send me a screenshot. I'll give you a shout out. And equally, if you want to spend a little bit longer with me, sit down and come on the podcast. We can do all that stuff too. So keep those messages coming in. But as we reach the end of this podcast, it's time to think about what we're going to talk about tomorrow. So I will spin the wheel of fortune that will determine what topic we will explore together. I'm not going to tell you what it is until you join me again tomorrow morning. Sorry to blackmail you all there, but hopefully you will come and join me again. But thank you for listening as always, and until next time, don't be a stranger.
Thank you for listening to the Tech Talks Daily Podcast with Neil C. Hughes. Remember, technology works best when it brings people together.